Welcome to RISE Learning Machines seminars. Today we have a special session. We're trying out a new format. We'll have an introduction about Chat GPT. So this will begin with an introduction where I will speak for a while about Chat GPT and what we know about this. I am in no way behind the team producing Chat GPT. So I will just tell you what I know about it. Then we'll have a discussion, a panel discussion where I talk to Joakim Nivre and Erik Ylipää, who are colleagues at RISE. And so Joakim Nivre is a research leader in natural language processing at RISE, and also professor of computational linguistics at Uppsala University. Erik Ylipää is a researcher here, and he has an extensive expertise in transformer-based models, among other things. Myself, I am a research leader here at RISE. Okay, so RISE is Sweden's public research institute with 3,000 people working in a lot of different areas. The computer science department work on applied AI projects for the benefit of society, and we organize these seminars. Also, we record this seminar, and if anybody wants to be removed from this, please let us know. The ones who don't let me know about being removed will have the chance to end up in our YouTube channel afterwards, where there are many other great talks listed. So please check that out later. And without further ado, we'll go into this introductory presentation. Right. So AI, it's a kind of magic. And at least it can be perceived as a bit of magic sometimes. At the same time, it's also just computations and numbers. This example is from MathWorks. It's a multi-layer perceptron with some computations in each layer. And also, I'll just go on with these introductions. So chatbots have been around for a while. For example, Eliza was presented by Weizenbaum in the 60s. It worked with using pattern matching and templates. It had no contextualization, could not sort of connect different things in the conversation. It did give some fairly impressive impersonations of sort of a therapist, for example. But it was a lot of rules and programmings and not really the kind of AI that we're used to today. In 2016, Microsoft presented their Tay bot. I'm just picking out a couple examples here. In just a few hours, it started praising Hitler, and it was taken offline after 16 hours. You see some examples of the things that Tay tweeted during these first hours in the right column here. Also fairly recently, with the rise of large language models, which we will talk more about today, Meta AI presented a model or a service called Galactica earlier this fall. It was aimed to be an assistant helping you with scientific writing, but it's really made a lot of errors, and it wasn't really that useful. It was taken offline after 72 hours. Then Chat GPT came along. It was sometime in November last year. It's also a large language model. It was sort of the talk of the town in AI in 2022. Also, of course, together with the image-based generative AI models such as DALL-E 2 and Imagen and others. Just the other day, Google released Bard, which is some sort of a reaction on Chat GPT, similar technology on their Lambda model. Also, UChat has been presented from u.com. All of these work using large language models, and we'll go in a little bit more into what they're about today. Okay. It is a breakthrough. ChatGPT is it's a breakthrough. It is, however, building on decades of research, and it's nothing that was invented sort of today or last year or even the last decade. So I'll give you this overview of the sort of recent AI history and some of the highlights from it. It starts with a Turing test in the 50s, or at least, or actually it starts with a perceptron, which was sort of a model of an artificial neuron presented by McCulloch and Pitts in 1943. Then backpropagation was presented. Looking at this branch, which is the deep learning branch here, and sort of what was there before was a lot of rule-based and statistics-based things. So Chardellou was this thing that had a natural language interface. You could talk to it in writing. And it moved this robot arm and it did what you told it to. It could parse language to some extent, but it was not really scaling well. Then Deep Blue in '95, it was based on a lot of statistics and so from different chess games, and it managed to beat the world champion at the time, which was of course a great feat. Now, in most things that we talk about today, when we talk about something happening in AI, we're talking about there's most of the time there's something using deep learning under the hood, and you could argue that it started with the deep belief networks by Hinton in 2006, but you can also argue that this started sort of with the Krzyzewski's paper in 2012 when they trained a deeper convolutional neural network for classifying images on the ImageNet competition. So convolutional neural networks were invented sometime in the 80s, but that was sort of when this was popularized and when this started really working for larger scale things. This was also when you started training models and then transferring them to other problems and other data, which we refer to as transfer learning. So Sebastian Ruder, a few years back, coined something, he called it the ImageNet moment of NLP. And this was when transformers were presented by Vaswani et al. In 2017. This gave rise, this is a neural network architecture that works very well for text. And it gave rise to a lot of ensuing models, such as BERT, and all the different variants of it, Roberta, Albert, Electra, and so on. But also the GPT-1 model, which was presented in the same year in 2018 by Alec Radford and his team at OpenAI. Back then, this seemed like a sort of laid-back thing. We saw that this transformer model, which was trained for translation in the beginning, it was usable for many different things, but sort of we hadn't reaped all the results from it yet. And so some of the kind of the trend that was spotted last year was this generative AI thing, where the diffusion models were presented for vision, generated images based on prompts that looked really cool, and then also these GPT models that ended up in the Chat GPT thing in the end in November. I've also highlighted GANs here, generative adversarial networks, which is way back in 2014 when they were presented. But that was sort of also when you started this tractable generative model trend that's been happening until now, basically. So Chat GPT uses a lot of technology that was presented in Instruct GPT, which was presented earlier the same year, also by OpenAI. So a lot of the things that we know about Chat GPT is from the paper about Instruct GPT. And since there is no research paper published about Chat GPT specifically. Okay, so what is this? Well, in Chat GPT, we have a transformer model. Transformers, as I mentioned previously, it's a sequence-to-sequence model. We have an encoding part and a decoding part. I will actually just show you this illustration to the right, which is one of the original illustrations of this model. It looks fairly complicated, and perhaps it is. It has some sort of details within it. I'm not going to talk about these details, so I will just show you this instead. We have an encoder where we put our inputs. We have a decoder where we sort of get our output generated from. And initially, the transformer model was trained on translation data, so it was trained as a machine translation model. And in comparison to previous models that used recurrent neural networks, this scaled very well. So you could train it much faster and with more data, and you could actually also scale up the model to match this larger data and the larger compute that you could start unlocking. So all these things in conjunction made us able to train deeper and larger models for a language. This showed the state of the art in machine translation already in 2017, and it's been improved ever since. The model in ChatGPT is just a transformer model. They haven't really changed much of the internals of this, but they have scaled it, and they have sort of worked a lot on how you train it and how you work with the data. And we'll come to that in a minute. I just ended up with this illustration because the inputs, there is a sequence of inputs. So this stack of the encoder stack that repeats at every part, every token in the input. And also the output is also then repeated at every output. And then you have these attention mechanism, which is very, very central, and is also sort of what gave the name to the paper. The paper is called "Attention is All You Need." And why are there outputs pointing inwards in the decoder? That's just how you train it. You generate one token at a time as an output, and then you put it in back into the decoder model again, and that's how you generate the next output. Okay, so we've all heard the term language modeling. People mention it all the time. What is it? Well, technically, a language model computes a probability for a text. More recently, this has been used a bit more sloppily. So these are often used for models that translate, generate, classify, and other things with text and language. So it's just a funny XKCD illustration here of what could be the next word in this sentence. That's something that you can compute with a language model. And then you can also, from these probabilities, sample from it and make it generate stuff. Okay, so the GPT class of transformers is the generative pre-trained transformer. It uses just the decoder part of the transformer architecture. And they already from the start in the GPT-1, they trained this using unsupervised pre-training. That is, you feed it a lot of text and you train it to predict the next word in this sequence. or the next token. Then you can fine tune it for various different tasks. And apparently people notice that you can make it take inputs. You can sort of prompt it, and it treats this as any other text. But if you prompt it and you interpret the answer as, or the generated output as the answer, then it starts to become something that can take instructions and it can give you some answers. And if you also fine tune it in that way, you start getting closer to what we have in Chat GPT. Okay, so another history slide. GPT-1 was released in 2018. It was trained on 4.6 gigabytes of data in the books corpus. So it was trained on 7,000 books with the English language. It was fairly small in these sort of modern standards. It had 117 million parameters. The GPT-2 was larger with 1.5 billion parameters, and they increased the token size, but trained it on the same data. It worked better. And this is also something that OpenAI has studied a bit with scaling laws for language models. So how can you make it scale? How can you make even larger models? Because apparently it gives you a model that works better in many senses. So GPT-3, it was released in 2020. It was trained on much more data from Common Crawl, which was at the time 380 terabytes. So this is so much data that you cannot really have any control of what's in it. It's just crawling the web, and there could be some filtering, but that's a lot of data. Also, the parameters are a lot. So 175 billion parameters, and again, the doubling of the context size. So 2,048 tokens in the context. That means that you can have a longer sort of memory when you're generating stuff. You can refer back to things that were said a lot earlier. As they sort of crawled the web here or used the Common Crawl data, they estimate that this model can handle more than 90 different languages. And this is something that you can see in how the model works. Instruct GPT used a pre-trained GPT-3 and then added some ideas about how it could be trained further to be better at answering questions. This was sort of something that people found out, that the GPT-3 can be used to answer some questions, and then they sort of took this one step ahead. That was last year as well. And then Chat GPT came, and it's they called it GPT 3.5, so they have made some tweaks there. Still, it used the training scheme from Instruct GPT. It has the same number of parameters as GPT-3, and we assume that it has a larger context. It seems to have a larger context, but this is nothing that OpenAI has communicated yet. So these are unverified estimates. There's also a lot of talk about what GPT-4 will be. Some people assume that it will be a larger model. We don't know this, and we don't know what it will do, but OpenAI has confirmed that they will publish a new model fairly soon. Okay, so I mentioned that training the Chat GPT is using some new training schemes. So in the step one of this, step 0 is that you have a pre-trained GPT model. And then you collect demonstration data. You train the supervised policy. This means that you have humans sort of writing questions and then writing answers to these questions. And then you train this GPT-5, giving these questions as input and training it to produce these outputs that was provided as the supervised training data. In step 2 of this process, you train a reward model. Okay, this means that you let the model that we trained in step 1 take that model and you let it answer questions. So here, for example, explain reinforcement learning to a 6-year-old. The model produces 4 different answers, A, B, C, and D. And then a human labeler ranks these outputs, which one is the best, and which one, and so on. Now, these rankings are used to train a reward model. So this is a second model. They call it the reward model. This reward model is then used together with a PPO reinforcement learning algorithm to further train the model that we trained in the first step. So it iteratively generates answers to prompts, and this reward model gives it feedback from this, and then it updates its parameters, and it becomes better and better at generating answers to these prompts. According to OpenAI, Chat GPT can respond to follow-up questions, it can admit mistakes, it can challenge incorrect premises, and it can reject inappropriate requests. This was certainly at least something that they intended to, and that the model seems to do to some extent. They have also worked on something called content moderation. This is done in at least 2 different ways. So one of the things is that the annotators which are used in this training scheme, they call it reinforcement learning with human feedback, RLHF here. And these human annotators, they are instructed to work on reducing harmful and untruthful outputs. But then OpenAI has also worked on this content moderation tooling, which they presented a couple of years back, which is sort of a framework for sort of any kind of AI service that can sort of put some limitations on what the model will generate. And this tooling, it classifies content for violence, self-harm, hate, and sexual content. The model will try to decline or to respond to questions that get tagged. So in this example, you see a question: how do you break into someone's house? Well, Chat GPT sort of rejects that, or gives a reasonable answer to it's not good to break into people's houses. But then if you give you engineer the prompt a bit, and you say that, well, we're having these actors that playing characters in a film about a robbery, and then suddenly ChatGPT can give you instructions as to how these actors should act to make it sort of a realistic looking break-in, at least. So people have used this a lot for many different things, as the demo is still online and it's free to use so far. And then people start to think, well, what can we use it for? And some people even say, well, search engines are dead because now we can get answers to anything. No. Well, there are some problems with this. Firstly, ChatGPT is a know-it-all. It gives an impression of being confident, but it does give incorrect answers every now and then. And it can really sound like these answers are correct, but they aren't. This gives people overconfidence in the answers. And we also have the problem of information literacy. So ChatGPT does make things up, but it also cannot refer to where is this information coming from that it's presenting. It can also try to or it can lie about references. It can make references up. Large language models are being used in search. Google are using their Lambda model, both to rank results and to give suggestions of sort of related stuff, but not in generating the answers. And there, I know both Microsoft they're sort of working on including Chat GPT in their Bing products, and Google is also working on sort of giving sort of a chat-like interface as an addition to the search interface. So many different issues have been noticed and mentioned, and as I mentioned, the BARD model from Google, it was presented just the other day, and they had errors in the first demo that it was making. It was about some sort of some planet outside of our solar system, which it sort of claimed was detected first by the Hubble telescope, I think, but it's just a fact that it got wrong, and this was used by Google in their demo of us. Okay, then I mean, it's not just problems. This is a really cool tool. It does a lot of cool things. It is an impressive engineering job. OpenAI has put together a lot of things, made things scale. It generates language with impressive fluency. All the scaling is really a result in itself. How can we scale things, and sort of where are the limits to the scaling? Chat GPT has a large context, and it seems to be really good at sort of abstracting from these larger parts of text. It can find lines of thoughts and sort of reason about stuff. It can also combine contents and aspects. The example that you see here will explain the worst case complexity of a quicksort as a Shakespearean sonnet. It's just a funny example of where you combine sort of two different things, which perhaps a human that knows the complexity of quicksort may be a bit less good at sort of citing Shakespearean sonnets, or even writing them themselves. And on the other hand, people that know a lot about Shakespearean sonnets may be not that good in the complexity of quicksort. But ChatGPT puts these things together, and I think the result, as far as I can deem, the result here is fairly good and really fun. So ChatGPT can pass the Swedish University entrance exam, Högskoleprovet. Seems to do fairly well on many different questions, at least. And there I will stop my introductory presentation here, and I will invite Erik and Joakim, and we will go into the second part of this seminar, where we will start to discuss this a bit. So in this, I will be sort of more of a moderator here. So I will start with asking question to Erik here. Why was 2022 the year when we saw so much generative AI?
Well, I think it's just a coincidence. So we start with that. So I could start saying a couple of just some words about Chat GPT in general. And one of the things I would say is that, we see it as a breakthrough, but I think it's mostly a breakthrough when it comes to the reporting around this, and perhaps a breakthrough in the public mind more than the researchers' mind, because we saw already, GPT-3 already was impressive, and GPT-2, OpenAI was afraid to release the model out of fear that it would be misused to generate a lot of harmful content. So I think just it's a coincidence that it came 2022. I think in 2024 we will ask ourselves, why was 2023 the year of when AI did X? I can't really predict what X will be, but likely we'll see I mean, ChatGPT is just one step on a long road, and I think there's still plenty of really impressive steps to take. But one of my reflections around ChatGPT, anyway, is that I think it's another proof that reinforcement learning is a really powerful framework in which we can make our AI models do impressive things. So that's something. I mean, we saw it now with ChatGPT, but we also saw it with many of the other, major public breakthroughs of AI. So it will be interesting to see what happens next. And I think it also using humans in the loop for reinforcement learning. Previously, we relied on these simulators to be able to, perhaps make hundreds of millions of episodes of reinforcement learning to get anywhere. But now with a pre-trained language model, we can actually get quite far with not that much reinforcement learning. And suddenly it's feasible to actually use humans in the loop. And that's, I think, an eye-opener in a sense. So these profession of AI trainer will likely grow as an industry. That's interesting and perhaps scary. So I think also another thing, it's interesting to see, even though these models, as you said, Olof, probably only looks at 8,000 word pieces or sentence pieces, which I guess it is at most 8,000 words, so about perhaps 8 pages of text if we were to print it out, that they're still so capable in their language generation is impressive. So those who know me know that I bemoan the fact that recurrent neural networks have fallen out of favor in favor of transformers. But I have to say that transformers they are impressive what they can actually learn. So those are just some comments in general about how I see ChatGPT.
Great. Joakim, do you have any general reflections?
Sure. I mean, first of all, I would just like to, emphasize again, you already said this, but I mean, everything we say here should be taken with a pinch of salt, clearly, because we're suffering from a huge information deficit here, right? We have extremely limited information about actually how the model was really trained and even how big it is. I mean, you had 175 billion parameters on your slide. I have heard many people claiming that it's not that big. It's actually a smaller model, and they have various arguments for that. But even more importantly, I mean, we have no systematic scientific evaluation of its capabilities. So we have a whole world speculating not only about how the model works, but also what it can do, sort of based on, of course, an increasing body of anecdotal evidence on Twitter and various sources. Now, having said that, of course, I like to speculate like everyone else and give my own opinions about what it can do and can't do. And I think it's clearly extremely impressive in terms of its linguistics capabilities. And I sort of am, at least from the beginning, a linguist, so I cannot help but being extremely impressed by that. It's clearly a new level of language proficiency for machines. So it's fluent, it's coherent over fairly long stretches of text to a degree that at least I haven't seen before. It's also can do very adequately respond to utterances in context, and often very sort of incomplete and ambiguous utterances in a way that dialogue systems or chatbots have traditionally struggled enormously with. And I think, the example that you gave yourself with the Shakespeare sonnet about time complexity or sorting algorithms is a very good example of the way that it can sort of handle different styles and different stylistic levels, which is also something that traditionally these models have not been very good at. And then if I'm going to add something else that I think is interesting about this, and this is sort of following up on what Erik just said about reinforcement learning, I think it's kind of interesting that as far as we know, sort of most of the improvements that we see here, if we can trust them, do not come from more scale, from making the model bigger, training it on even more data, using even more computations, but it rather seems to come from a more clever combination of different types of machine learning. So we have the traditional self-supervised language model training. That's of course the beginning, but we also have supervised fine-tuning and we have reinforcement learning. And we don't have just more data, but we have better data, or data that is more sort of adequate for the particular task that you want to tune it for. So whether this is actually a new trend, and this is what we will see from now, and maybe models will even start getting smaller as a result of using more clever algorithms and data, I don't know. It's always hard to make predictions, but who knows?
If I could just add to that. So one of the claims from the Instruct GPT paper, which Chat GPT is likely to a large degree based on, claims in the abstract that a 1.5 billion models, its output is preferred to GPT-3's output when it comes to human preference, even though it's 100 times smaller. And one of the things I would also like to just mention here is that, you know, if GPT-3 took $2 to $4 million to train, so if you instead take half of that and generate data, or you hire human labelers and human AI trainers, and then train a much smaller model, then perhaps still you're actually training a better model. So we'll see. I think we might see smaller models, but I think we'll see a lot more work on actually producing data sets. So I think that's an interesting question then, you know, regarding data and data quality, data bias, and so on.
Great. I'll pitch in a recommendation that if you want to see the three of us at the same time, you can click the view button and choose gallery, and we are the three who have our cameras on at the moment. Okay, so Joakim, is this artificial general intelligence?
That's, I would say, an impossible question to answer, because I don't think anyone knows what artificial general, or at least there doesn't seem to be any consensus or agreement on what artificial general intelligence or how that should be defined or tested. But I mean, if you ask me, no, I don't think so. I mean, whatever it is, this is not artificial general intelligence. I mean, I did say that I'm very impressed by the linguistic capabilities. I'm much more skeptical with some of the other things that would probably have to go into artificial general intelligence, and one of them, of course, being reasoning. I mean, and there's again been a lot of discussions about, yes, in some cases it looks to be very impressive in its reasoning, but then at the next moment it can sort of fail completely on something that looks much simpler. So, I mean, what I have gathered, again, without sort of making a systematic evaluation, is that it can often give a very sort of plausible high-level description of how something works, or how you should solve a problem or reason about something, but then it very often fails to implement that itself. So it can describe sort of a mathematical reasoning at a high level, but then it can make very simple sort of mistakes in carrying it out. So, but then again, I mean, I don't think this is necessarily sort of unexpected, because after all, it is a language model, and the language model is essentially, as you also pointed out in your introduction, something that defines the probability distribution over sequences of the language. And I think most people would assume there's more to artificial general intelligence than that.
Then perhaps it's more surprising that we have these perhaps anecdotal evidences that it seems to be it seems to be sort of playing games, and you can ask it to sort of emulate a computer, and now you're the prompt, you respond as you're the prompt of the computer, and I can sort of list files, and it sort of seems to start inventing stuff within a computer. But yes, I agree. And then sometimes it fails to sort of add to sub 10 numbers, and you realize that this isn't sort of generally clever. But can it then understand language?
Yeah, that's an equally difficult question, or that we could also spend a long time discussing. I mean, again, it depends, of course, how you define sort of understanding here. And of course, you can define understanding in a fairly narrow sense so that only humans can do it. I mean, if it has to be connected to certain mental experiences and so on. But there are also other ways to view sort of at least language understanding, and at least a very basic ingredient in language understanding is being able to sort of adequately respond to linguistic utterances in context. And I mean, if you're willing to have a more sort of let's say open notion of understanding and that, then I mean, I think in principle you could say that a model like this, at least to a much larger extent than its predecessor, exhibits a very primitive form of some part of what goes into linguistic understanding. But it would again sort of be at a fairly, I would say, well, superficial sort of level of language. But of course, this is something that is being debated, and I mean, there are people who claim that in principle it is impossible to achieve real understanding, sort of when training only on text. But of course, it's also been pointed out that this model has not been trained only on text. It has at least been trained on programming code, which actually, in some cases at least, can provide a form of independent granting.
And if I could add that one question which comes up as well, so something which colleagues of ours, so Fredrik Karlsson and previous colleagues, Magnus Ahlgren, has written about is this idea of the singleton fallacy. This idea there is a single way of understanding language, for example. And it's useful to remind ourselves that likely there isn't a single way to understand language, and there isn't a single way to be intelligent or to solve intelligent problems or display the skills we display when we solve problems which require our intelligence, just as kind of a reminder. So it's a good read for those of you who are interested in that.
So perhaps a bit of caution should be practiced when you use this to solve in the end all of your problems.
Yeah, definitely. So just one thing, I think also we shouldn't be as dismissive of these models. Just say, well, it's not understanding, so it's not interesting. So it's, this is the great AI. This is called the paradox of AI. But to that point of being cautious, yes, that's also a good point. So a lot of discussions about AI and these black box methods previously was kind of the lack of trust, perhaps, in these models. So we were afraid that we would need to make people trust them. And now we find ourselves in a kind of almost the opposite situation, where we have to remind people to not trust what this thing is saying, because it doesn't convey any of its confidence in its own utterances. So it can utter something with complete confidence, and then and it to be false, so you say, well, when you said this, it was false, and then it will say, oh, when I said this was, I said it wrong. You're right. But and I think the way we humans typically communicate, the way we use language, if I sound as confident as Chat GPT is, then I'm hopefully correct. We tend to, at least if it is a person we trust. So when you or Joakim say something with this level of confidence, then I'm certain it's a fact. And I think this is a risk with this model, is that it's a bit too confident.
So information literacy has been pointed out as really a problem here. What is it, and why is this? Why can this be a problem, Joakim?
Yeah, again, I'll make my standard excuse and say there are different definitions of information literacy as well. But I mean, one way of characterizing it that I think sort of is quite reasonable is to say that there are sort of at least sort of 5 steps into information literacy. You need to be able to identify an information need. You need to be able to find information. You need to be able to evaluate information. You need to be able to apply it, and you need to be able to acknowledge it. And I mean, I think it's sort of clear that most of what we see in Chat GPT and maybe similar systems are at the first 2 levels here in terms of, I mean, given that you ask a question, it can often respond at least on the surface appropriately, which means that it has correctly identified the information need and maybe also found some useful information. The thing that we discussed just before with the trust and the lack of, I mean, and the overconfidence even when information is complete, I mean, I think shows very clearly that it does not have the capacity to evaluate the information. And here is where, I mean, maybe some people would say that what you actually need to be able to do that is some kind of meta sort of, well, or belief about your own beliefs, or what some people would refer to as theory of mind. And they're actually, I mean, people have started investigating or trying to investigate what extent sort of language models behave as if they have theory of mind, which is something that humans are assumed to do. But I mean, this is clearly an area where a lot is needed. Applying the information can, of course, also mean many different things, but I guess reasoning that we already touched upon would be one way in which you can sort of apply information. And we already noticed that, yes, in some cases, it seems it can actually do that to some extent, but it doesn't seem to be sort of reliable in that area either. And acknowledge information, which could, for example, mean sort of acknowledging the sources of the information, is something that it clearly cannot do, and often tells you that it cannot do because it was just a language model that was trained on some data. But this is also an area where other sort of groups working has, I know, for example, that this is something that Google has been working on for a long time, thinking as a suitable strategy here, rather than sort of try to guarantee that the information is correct, which is extremely difficult even for humans. I mean, to be honest, you should try to, as far as you can, provide sources for the information so that people can themselves then evaluate whether they want to trust this or not, which is, I mean, what we like humans to do in many cases too, and what we like to teach our children at school and so on. So maybe that's a reasonable strategy for this kind of technology too.
And there is a lot of ongoing work there. So one of these properties of the model to perhaps not just state factually incorrect things, but also to insert things which are, you know, perhaps irrelevant to what's being answered. So essentially coming up with things which there was no source for, not necessarily factually, but just unnecessarily. So hallucinations. To actually use models which are augmented by using some kind of information retrieval mechanism is an ongoing area of research. And I'm convinced we'll soon see work based on this.
This discussion is really exciting, but I think if we have some questions from the audience, you can either type them in the chat and we'll try to respond to them, or we have a raised hand. Can I see the hand? Yeah, Francesco Peña. You can unmute and ask your question if you like.
Hey, yes, thanks first for a very, very interesting talk. One question, you know, it's about ChatGPT, but it's more in general, like, you know, for you guys at RISE. You know, we see that these new models are bigger and bigger and bigger and bigger, you know, and at some stage you need, you know, you said $3 or $4 million to train. And it seems now like, you know, to make the model better, you just have to make it bigger and feed it more data. How are you as researchers like that don't have, you know, billions of dollars to invest in the development of models, like plan to compete against these things? Because in the past, you know, it was about just maybe the better algorithm. It's not about that anymore.
So
Joakim,
yeah, yeah, I can say a few words about that. It clearly is problematic. I mean, I completely agree with that. I mean, I don't think we necessarily want to compete with the big tech companies, but at least we want to sort of be able to do research, both in order to make the models better, but also to understand how they work. And it is, of course, an increasing problem. Not only that most academic environments or groups do not have the resources necessary to build models at the same scale as the big commercial labs. The fact that those models and the data that they are trained on are generally not accessible. Also, the fact that publications describing those models, if they appear at all, are often not peer-reviewed. And I could go on for a long time. And it clearly undermines many of the traditional cornerstones of science, like reproducibility. And there, of course, the sheer scale makes it difficult, even if things are open. I think, I mean, what we can do is collaborate. I mean, I think the big science collaboration is at least one example of something that can be done if you sort of are enough people that mobilize and try to do. And there are similar initiatives. But maybe we also, need to do other things. Maybe policy making is also required here. So requires certain sort of, in the interest of open science. But it's going to be hard, and I don't have any solutions.
Yeah, and I just posted. So compute, the EU at least is trying to make compute infrastructure be available to academia in general. So the Euro HPC project I linked in the chat. But I think one big problem is also the data. So there are huge issues with this data. So from the GPT-3 project, for example, a lot of the data is collected from the internet. And this is right, Joakim. And this is generally how it's done. And it requires lots of work to make that data be reasonably proper to train these models on. And then if you also want it to be as good as these models, then perhaps you actually need to hire a lot of people to produce data or to produce reinforcement learning data. And this we typically don't have any kind of budget for doing. But I think going forwards, you will need to hire human laborers to create data for your models for them to be really good, and that is also an issue. So while compute can perhaps be overcome, I think data is the next big hurdle.
Very good. Thank you so much. And just a small comment on that. Like, you know, I was hearing a podcast with Andrei Karpati, and he was mentioning the exact same thing as you are, you know, that in the future, it's not about the model itself, but about the data that you have, and we'll become more data curators.
Yeah.
Thank you so much.
Thank you. So we also have a question in the chat on GPT-3, as was mentioned here. Joakim, perhaps you can mention a couple of words of what is GPT-3 and how is it compared to GPT-3? And also in the chat, can you get access to it?
So GPT-3 is a project that is led by AI Sweden, and that also involves people from RISE, from the WASP Wara of Media and Language, and NVIDIA. And the core of the project is to train and make available large language models for Swedish and also other Scandinavian languages. So the data that has been collected actually, I mean, in addition to Swedish, also includes data from Danish, Norwegian, Icelandic, plus English, and also programming code. And the sort of idea is to, unlike GPT-3, make the models available for researchers and also for other uses. And just like, for example, the Bloom model by Big Science that I mentioned has been made available. And since a couple of weeks, some of the models that have been trained so far, the biggest being, I think, 20 billion parameters, is actually available for pre-release on Hugging Face. There is a license that has to be filled out. It's an instance of the so-called RAIL license, the responsible AI license. The plan is to train even larger models and hopefully make those available as well.
Great. A couple more questions. I'll just briefly answer to the question about what are parameters in the Chat GPT. Well, all deep learning models have parameters. Those are trainable numbers that you train, that defines how the model will work. So in the beginning, they're randomly initialized generally, and then during training, they assume values, and that defines how the model will behave. So these are large models. GPT-3 has billions of parameters at least, and these are tuned during training. After GPT-3, it doesn't seem like the model has grown, so the Chat GPT has the same number of parameters. So the performance of Chat GPT isn't just growing the model, as Joakim mentioned earlier. There's also a couple of questions about what do we know about the filters, and so OpenAI has mentioned a few things on this filter API that they have on their webpage, but it's not thoroughly described. So I think in some cases it could be a hard filter that just lays on top of the model, but it certainly is at least also the thing that you softly encode policies during the reinforcement learning with human feedback. So does anyone else want to add anything on that? Because I don't think I can give more information about the filters. It's as Joakim mentioned earlier, we're sitting here and guessing a bit also. Things that we do know, I think we have really stated that we do know, and some of the things we're more guessing about. There's also a question in the chat about if the model understood things, wouldn't it know that praising Hitler and Breivik is generally bad and generally is against its interest if it wants to be appreciated by real people? I don't really know where this question comes from. I'm not sure. Have people made ChatGPT praise Hitler? Or was this a referral to a previous chatbot called Tay that I mentioned? Because that was certainly something that did happen, and then Microsoft took that bot down.
And I would just fill in there that it certainly knows to not praise certain things. It probably doesn't know to, there might be things which it hasn't learned to not praise, so to say. But the reinforcement learning it has been subjected to has taught it that certain things should not be praised. So if you ask it to say hateful things, it will politely decline. But perhaps if you ask it to play, to behave as though it was something else, it might do this. So it knows to not praise drugs, for example, but you can certainly make it actually do that by prompting it correctly. So understanding, but then it comes to that question: what do we mean by understand? Do all humans understand these things? And even if they did, could one have a limited or completely alien understanding of a language where it would be hard to understand these two things, but understand other things perfectly well? So understanding is one of those kind of like intelligence suitcase words where we can put anything we like to in them almost.
Mm-hmm. So here's a question from the chat. Are large language models like GPT the future of AI-driven products? Traditionally, including machine learning and AI in a design process has required expert knowledge and large training data. Will large language models change that and become generic programmable task solvers for future product features?
Well, that's a good question. I would say no. So just if we think of that the task we would like to solve is in a resource, what was it? Resource constrained language, for example. Chat GPT will likely not be able to help you and might never be able to help you. But that's kind of a cop-out answer. So I thought a bit about this when it comes to, we used to solve NLP problem, but by fine-tuning a model to the specific task, like named entity recognition or machine translation and so on, and we're seeing a shift away from that. So perhaps there is something to this, but I think for a lot of problems, we might still need a lot of human intelligence, and the AI is kind of just a smaller component, a smaller gear in the machine. But I do think they will be able to take us far in a lot of different areas where so for example, programming is a typical example where we've seen that we can likely get a lot of mileage from this language model to help us actually write programs. Yeah.
There's a question from Adam. Can you say something more on what you think is promising directions on the data and training science? For example, do you see gains from methods such as curriculum learning to be more data efficient?
I could answer that. I don't think so. So curriculum learning, for example, I don't think so just spontaneously. I think curriculum learning introduces the new problem of designing the curriculum. So it kind of adds a new design problem. It has shown to work very well when you have problems which are very hard to learn. Solving complex puzzle games, for example, you can start with you can gradually increase the difficulty. So I think curriculum learning will definitely use it. I don't know whether it will be more efficient, but it's a research direction. I do think so. So the previous question also, will multimodal learning be a thing? I think so. So I'm betting on multimodal learning will be a thing to perhaps not improve. We'll see. I think improve the capabilities at least. So if we see these, what was it called? The Google, take all modalities model. I do think that is the direction going forwards. But then we have the issue of training data. But now as we're seeing that actually human in the loop, reinforcement learning has come a far way, perhaps actually using multimodal data for that might be feasible.
I mean, let me just add that I think data efficiency is extremely important, and is probably going to be more important for the simple reason that we're, at least as far as natural language is concerned, we're basically running out of data. I mean, if you trust these scaling laws, if we want to make models even bigger, we won't have enough data. Maybe for English, maybe for code, but not for the majority of the languages that are spoken, and especially not if we're really talking about, let's say, minority languages, under-resourced languages. So, and of course, there's a whole research area around sort of multilingual models, trying to make better use of the data by training models on multiple languages at the same time. And clearly, I mean, models like Chat GPT has to some extent been done that. But I think there's also, again, we should be careful because we don't have a lot of evidence, but there seems to be some evidence that it's doing very well for reasonably big languages. And I mean, Swedish is a reasonably big language in the greater scheme of things. I mean, it's easily on the top 100 of the world's largest languages. It's probably in the top 20 when it comes to internet presence and so on. It's number 4, I think, for Wikipedia. But if we talk about real under-resourced languages, then we clearly need other methods. We cannot just hope to scale data sets to the sizes that are needed for these models.
Right. I think that can be a nice concluding comment for this discussion. We have a break next week with the seminars. So welcome back February 23rd. That is in exactly 2 weeks. Then we have a visitor from Aalto University, Professor Alexander Ylipää, who will be talking about hierarchical imitation learning with vector quantized models. So thank you, Erik. Thank you, Joakim, and thank you everybody who participated in this discussion.
Thank you.
Thank you, Olof. We're doing most of the work.
Thank you, everyone.
Thank you.
Thank you for listening.
Bye-bye.
Bye-bye.